Welcome to the first superlab of the year, EMI502. Determine whether given information supports or contradicts a simple hypothesis and why. In front of you right now, if you are at home watching this video, you should have the skill sheet so you can follow along with us. We're going to get started by going through the background. EMI502 is a skill that requires you to look at data from an experiment and determine whether or not the data agrees with the hypothesis or conclusion that is written in the question. The answer choices will present you with a variety of options that either support or contradict the hypothesis or conclusion in the question. The thing that makes these questions a little bit different is not only do you have to determine whether it supports it or not, but the why part can almost be trickier than determining whether or not it supports it. All right, so these are actually like two-part questions every time. Let's get started by reading the passage together. If you're listening at home, what you should have in front of you is a pen, pencil, or highlighter. As we go through and read this together, you should circle, highlight, or underline any words that jump out at you that are tricky or confusing so that we can clear them up now. All right. A bomb calorimeter is used to determine the amount of heat released when a substance is burned in oxygen. The heat, measured in kilojoules, kJ, is calculated from the change in temperature of the water on the bomb calorimeter. Table 1 shows the amounts of heat released when different foods were burned in a bomb calorimeter. Table 2 shows the amount of heat released when different amounts of sucrose, also known as table sugar, were burned. Table 3 shows the amounts of heat released when various chemical compounds were burned. All right, so everybody take 1 second and go through. Are there any words that you circled, highlighted, or underlined that you would like to go through right now so that we have the definitions of together? Any words in there at all? A calorimeter, fantastic. Nice. That's a tool we haven't used in class before, a calorimeter. Any other ones? Sucrose, nice. Sucrose. Nice. Any other words? Unfamiliar? Going once. Going twice. Sold to calorimeter. All right, what we're going to do now is we're going to try to figure out these words. In science passages, there's really 3 different ways you can get vocab. It's either defined directly for you, you can figure it out based on context clues, or you have to look it up. On the ACT, we can't look it up, so we try to avoid that. Let's start taking a look at calorimeter. Does anyone see calorimeter as a definition anywhere? Does the passage tell you what it is? What is it? Excellent. So is the calorimeter the amount of heat? Perfect. It's the tool that we need for that. Perfect. So it's the tool used to determine the amount of heat released when a substance is burned in oxygen. All right, you light it on fire. How much heat does it release? All right, this is actually how, whenever you look at your food items, they determine how many calories are in the food. All right, as you burn it. All right, 1 kilojoule is representative of 1 calorie. All right, that's how you look on the packaging and it says how many calories there are. They use a bomb calorimeter. All right, the second word we have is sucrose. First thing we have to check for is sucrose defined for us in the passage. Yep, where is it? Next to it. Yeah, the thing in parentheses. Things in parentheses usually describe the things before it. Sucrose is just table sugar. All right, we notice that it ends in ose, and so we know it's a sugar. All right, we learned that. All right, and specifically the type of sugar is the kind of sugar that you put in your coffee or that certain students put on their Twinkies, which was a bizarre discovery in class. Okay, let's jump into the next one. All right, this is what a calorimeter actually looks like. All right, what you'll notice is that there's kind of an outer container right here. Inside this container, it's actually full of water. We see the label here that's describing all the water. There's a thermometer that goes into the water, so it's constantly measuring the temperature of the water. All right, there's also a stir to make sure that the water stays mixed well, so the heat all isn't in one location. The steel bomb is the inner chamber here. And so what happens is that this little firing element right here burns the sample of food right there. however much heat released, the heat from the thing on fire, that heat will go to the outside of the steel container and cause the temperature of the water to go up. Every degree Celsius that 1 milliliter of water changes is equal to 1 calorie. So if there's 100 milliliters of water and it changes 100 degrees Celsius, that would be 100 calories. All right, that's just more for fun knowledge. All right, it's not really necessarily integral, but it is important to know that we're measuring the change in water temperature here. That's then going to tell us how much energy is. All right, the higher energy the food, the more heat it'll release. All right, if it's a real wimpy food without a lot of energy, all right, like celery, there's not a whole lot of energy in celery. It won't heat up the water very much. But if you were to burn something like gasoline inside of there, there's a ton of energy in gasoline, and that'll really heat up the water. All right. And that's why your car is powered by gasoline and not by celery. All right. Let's take a look at the next one. We see 3 different tables here. What do we see in these different tables? What is being represented to us? Yeah, the first one we see food. All right. These are foods that they put in where? What did they do with these foods over here? Yeah, they burned them in the calorimeter. All right. How much of them did they burn? Yeah, in this case, all of them were burned in equal amounts. All right. You see how much the water temperature changed? They then used and converted that into how many kilojoules of energy. Ta-da! What about the next table? What's different about the next table? Right, only one food. And so instead of using multiple foods like we did here, now we're only using one food. And what else is different? So at this point, the food is staying the same, but what's changing? Yeah, and now we're changing how many grams they used. All right, in the first table, it was all 1 gram, different foods, different energies. Now, same food, but different amounts, again, different energies. All right, last but not least, what's table 3? Table 3 is a little weird. Yeah, now we're using chemicals instead of food. So you see methanol, ethanol, benzene, and octane. Octane. All right, same amounts or different amounts? Same. All right, now we're all using the same amounts here. And we can see they all release different amounts of heat. Perfect. Okay, any question about these tables? All right. Using this information, you can now answer this example question. Is the statement 5 grams of sucrose will release more than 64 kilojoules of heat supported by the information in table 2? This is where these questions really start to get tricky. How you attack them, the first thing you need to figure out, is the statement true? The second thing you have to figure out is, why is that statement true? So let's do the first part first. Is the statement true that 5 grams would release more than 64 kilojoules of energy? All right, I see heads nodding, so that if we put 5 right here, we would expect that number to be greater than 64? Right, yeah, it would have to be something higher than 64. All right, because as we see this trend, as the grams increase, as we move down, the temperatures also do what? Increase, all right, on the way down. So we'd expect 5 to be more than 4, 4 is more than 3, 3 is more than 2. So now we know 2 things. We know, yes, the statement is true. We also know why. Because as you increase the grams, you increase the heat. 2 parts of the question. We have to be aware of this because that's what we're going to be looking for later. Okay. What you want to do if you are at home right now, or if you're sitting in the classroom, is you want to halt the 3 tables. And in fact, don't forget we're halting here instead of halting here because we're looking at tables. So instead of talking about axis labels, we flip it around and we're talking about variables, which are the things at the top of every column. All right, take about 2 minutes right now. If you're at home, you should pause the video, fill in the halts, All right, when you've finished filling in all the vaults, press play and we'll go through them together. All right, if you are pressing play at this point, that means you've already gone through and done all of your vaults for Table 1, Table 2, Table 3. Listed up here already is most of the H, V, U, and L, as those are the more straightforward parts. So in these cases, you should have filled in food here. Heat released is the other variable not listed. Grams would be the unit for mass, and degrees Celsius would be the unit for change in water temperature. There is no legend, and so let's get to a trend. There's a lot of different ways you can make trends, remember. You can do highest points or lowest points. So let's do a couple as some examples. What's one example? All right, so we're using a highest point there. All right, this student pointed out that cheese has the highest change in water temperature and also the highest heat released. Good to know. Great trend. Does anyone have another trend that they want to share? Okay, so this student said as the change in water temperature increases, the heat released also increases. Now this is a variable relationship, but it's a little bit tricky to see. Why is this one trickier to see than maybe some of the other ones that we've done with this before? Why is it harder to find that relationship that as water temp increases, the heat also increases?
Because it changes, the water temperature changes at cheese.
Yeah, good, because they're not in like a good order. They're not from lowest to highest in either regard. So if you were going to do a question like this, you'd have to, in your head, pretty quickly put these in order. The easiest way to do something like this, if you're looking for this kind of relationship in a table, is to just put a number next to them as to where they stand in the table. All right, so we're going to put a 1 next to the lowest thing and a 4 next to the highest thing. All right, so in our change in water temperature, where would be the 1? What's the lowest change? Potato. We put a 1 there. Then what? Then egg would be 2. Bread is 3. Cheese is 4. So now what we're going to do is if we imagine that these were in this order, 1, 2, 3, 4, what we can do is do that again for another variable and see how that matches up. If we look now at heat released, where would we put the 1? Potato. Where would we put the 2? Egg. Where would we put the 3? Bread. And where would we put the 4? Okay, now what do you notice about our temperature numbers and our heat release numbers? They're the same. So in this case, if they were in order, it would go lowest to lowest, then this one, then this one, then this one. And since both columns do the same thing, you know the variable relationship is this. As one increases, the other increases. The only other real useful thing you could pull from this is if instead of the order we had, if the order instead was 4, 3, 2, 1, what would you be able to learn from that? If now the lowest change was the highest heat, and then they kept changing the whole way up, what would this relationship be? As temperature increased, what would the heat do? Decrease. So if you saw an exact opposite, you'd be able to say the other relationship. No, that's not true. In this case, we don't have to worry about it. Good. Let's jump on to the next one. Can anyone give us let's see, the blanks we filled in were heat released was the other variable, kilojoules was the missing unit, and there was no legend. Can anyone give us a trend? As the mass increases, the heat released increases. Now this one's easier because they already put these in order for us, so we don't have to rearrange this order. Nice. Any other one? What's the highest, lowest point where things are the same? Anyone have any other trends? Yeah, I mean, in this one, this is probably the biggest trend to pull out because you could also say when there's more sucrose, there's more heat released, but you kind of covered that with your variable relationship. Last but not least, let's take a look at this one here. Did anyone come up with a relationship here?
As the mass remains constant, the heat release increases.
Okay, that's a good thing to figure out, is that all these masses are the same. The heat released increases. All right. So what that tells us is that it's not the mass that's causing the change in temperature. It must be something else. All right, and in this case, it's because there's a whole bunch of different chemicals being used. It's not the same chemical. All right, which one's the highest? Octane. Which one's the lowest? Methanol. Good. Yeah. All right, I think we're ready to move on. Let's start to tackle some of these questions. So what you want to do in your teams or on your own if you're watching at home right now is answer 2, then 3, then 20, then 23. When you've answered 2, 3, 20, and 23, you should press play and we'll go through the answers together. At this point, if you're watching at home, press pause so that you have some time to work on them. All right, if you are pressing play at this point, that means you've answered 2, 3, 20, and 23 and are ready to go through the answers together. So first, let's get started. Which releases more heat, 0.5 grams of sucrose or 1.0 gram of egg? Let's answer this question. Good, 0.5 grams of sucrose. How did you get that answer? Nice. All right, this was a pretty basic question that was asking you just to be able to figure out how to use the tables. When it says 0.5 of sucrose, you have to find 0.5. When it says 1 of egg, you find, well, the only egg that's available, and you're done. Let's take a look at 3. Which releases more heat, sucrose or benzene? The hint here is really important for understanding pretty much the entire rest of this passage as well. What'd you get? Sucrose. Sucrose? That doesn't seem right. Benzene? That doesn't seem right. If I look at benzene, it's 21. Sucrose has 64. It seems like sucrose should have more than benzene. So shouldn't the answer here be sucrose? 64 is higher than 21.
Because benzene has 0.5 grams, you have to look at 0.5 of 13.
Fantastic. You have to make sure that you're comparing the same amounts. That's what the hint says. Remember to compare the same amounts of each. It's not fair to compare 4 grams of sucrose to only half a gram of benzene. That's not a fair comparison. It's like saying if you burnt an entire pile of logs, that it would have more. Well, that's a terrible example. I can't think of a good example. But you got to compare the same amounts. All right. So in this case, if we compared same amounts, we only have one amount of benzene to use. So we have to then use sucrose. We have multiple amounts that we can compare. If we compare an even amount, which was 0.5, just like the 0.5 was down here, now we see that 21 is much higher than 8. So the answer here should be benzene. Okay, let's jump on to 20. According to tables 1 and 2, as the mass of successive sucrose samples increased, the change in water temperature produced would likely, now this is a variable relationship. We're trying to find the relationship between mass of sucrose and change in water temperature. All right, what are we looking at for the answer here?
I like that table too. It says sucrose.
Yep.
I like that it's increasing. I like the heat release and that doing that as well.
Okay, so in this case, as the mass increases, the heat release does increase, but what we have to be careful of is what is the question actually asking us to compare? Mass to what? Right, because we want to compare the mass not versus heat released, but we want to compare mass versus what? Water temperature. Yeah, we care about water temperature. In this case, what we have to do is a little bit of going back to what we already said and know that as heat released increases, what do we know about water temperature? Yeah, we already discovered that water temperature increases. So we can make that same relationship. And that's the whole point of having this whole table 1 thing in there, because it doesn't really seem like you need table 1 until you figure out that, wait a minute, you then have to convert heat released back to change in water temperature. All right, but we already did that a while ago, so we're perfect. Question? Well, remember, that's why a while ago we did this. Because these aren't in order here, we had to put them in order this way to compare them again.
So we wouldn't do that disclosure that they would get it wrong.
Probably because, yeah, you wouldn't really want to say like as one increases and decreases, the other one increases and decreases because it's not as strong of a relationship as what they actually have. Yep, good question. Okay, last but not least, before we move on to the next section, which of the following lists the foods from tables 1 and 2 in increasing order of the amount of heat released per gram of food?
I looked at table 1 and 2 and it says increasing order amount of the release. So then I saw that on table 1 has the food.
Okay, so we're looking at table 1 for the foods.
And then I saw that he releases first potatoes, then is egg, then is bread, and then cheese.
Okay, so you put them in order first that potato was the lowest, then egg, then bread, then cheese.
And it says on table 1 and 2 is increasing order release per gram. It said A.
Good. So you just went through, and the only option was A, or why did you not pick D? Because D puts them in the same order that you had. But you have sucrose right here.
For table 2, it doesn't have the, how do you call it?
Yeah, well, how do we, so we need to either include sucrose before potato or in between bread and cheese. So how do we know where sucrose would fall in this order? 0.1, but right, 1.0. Nice, because all these are 1.0. We need to make sure we're looking at sucrose at 1.0. Sucrose at 1.0 is 16, which would fall in between bread and cheese. So that's how we know it's A and not D. All right, so that first step you did was nice because it totally eliminated B and C as options. We knew those couldn't be right. So then between A and D, we got the right answer. All right, what you want to do right now if you are at home is answer questions 4, 5, 6, and 7. Once you've answered questions 4, 5, 6, and 7, press play, and we'll go through the answers together. These are the last ones. If you can answer these, you can answer any of them. Please make sure that you read the hint in question 4 because it tells you how to answer specifically EMI502 style questions. You first determine if it's true or false, which allows you to eliminate half of the answer choices all the time. All right, if you figure out the statement is true, you can cross out all the no's. If you figure out the statement is false, you can cross out all the yeses and then just work from there and you only have 2 choices and then figure out which one's right. All right, if you're at home, press pause now, press play when you're ready to go through the answers. All right, so as we start taking a look through these questions, let's just make sure that we can tackle 4, which kind of has the hint still on it. So is the statement, and our statement is here, bread contains more energy than egg. Is that true or false? What do we think? True? How did you get true?
Because I looked at the bread, the egg, and I see that bread is 10 and the egg is 6. So 10 is higher.
Nice. So bread is higher than egg. So immediately, which 2 can we get rid of? C and D. We don't have to worry about them because the nope's not true. So now we only need to figure out which one's true. Egg released more kilojoules than bread, or bread released more kilojoules than egg.
Yes, because bread releases more kg than egg.
Perfect.
Because if you go to table 1 and you go to egg, the release 6.7. And bread release 10.
Perfect. All right, the same 2 numbers we compared to figure out yes are the same 2 that are compared in the explanation. 10 is higher than 6.7, so that means B is true, A is false. We go with B. Let's keep on going. It was concluded that sucrose contains more energy than cheese. All right, first off, true or false?
False.
False. Why?
Because
don't know. It seems to me like sucrose has 64 and cheese only has 17. Seems like sucrose is higher than cheese.
It would be like that because you're not starting at one.
Nice. We only care about when they're even amounts. So now we're comparing 16 to 17, and now cheese is greater. So sucrose contains more energy than cheese. Which ones do we get rid of? We get rid of A and B because it's not yes. So we're only left with no. Sucrose releases more energy than an equal amount of cheese. Is that true? No, it's not, because when they're equal amounts, they're different energies. What about sucrose only releases more energy than cheese when you burn more sucrose than cheese? Yeah, that's what we discovered. Perfect. All right, which brings us to D. All right. If the hypothesis 0.8 grams of sucrose will release, is the hypothesis 8 grams of sucrose will release 128 kilojoules of heat supported by the information? Let's take a look at the information. Is this true or false?
True.
How did you get true?
Because I saw that it's saying that 8.0 sucrose will release 128 kg. And this said it's supported by the information. And then I took that since it's so I just eliminated no.
Okay. How did you know that that was true?
Well, because it says which one of them will release.
What kind of pattern do you notice in these numbers?
Oh,
That
they go
like,
by two.
yeah, every time you double here, this doubles. Double here, this doubles. Double here, this doubles. You double 4 to get to 8, you'd expect 64 to double 128. So we know that it's yes, or we know that it's no?
It's yes.
We know that it's yes.
It's yes. Double it. The heat release double.
Nice. All right. The fact that the heat released halves, that is not true. B is true. All right. Last one. Oh, geez. All right. Does the data support the hypothesis that more hydrogen atoms a compound has, the more energy it will release? Well, let's take a look through. Let's number our hydrogen atoms. This has 1. This has 5, 6, 18. So this is increasing. You also see your energy increasing. So that statement is true, right? No, it's not.
No, because there's two H's and
6. Right. There's actually 6 H's here, not 5, because there's an H here plus 5 more. That means there's 6 total. So then this relationship no longer makes sense, because if they have the same number of hydrogen atoms, you'd expect them to have the same heat released if that relationship was true. But that's not true, so the relationship can't be true, which means you can get rid of your yeses, and all you have to do is find the one that matches, so that ethanol and benzene have the same number of hydrogen atoms, but different amounts of heat released, which should be D. All right, congratulations, everybody. You are ready to take the quiz. Good luck.